A Mississippi boat cruise sailed 120 miles upstream for 12 hours and then took 10 hours to return to the dock. Find the speed of the river boat in still water and the speed of the river current. In this problem, we're looking for two speeds. The speed of the river boat in the still water and the speed of the river current. And we see that we have units of miles and hours. So those speeds will be in terms of miles per hour. Let's introduce some variables. I'll let B represent the speed of the boat in still water. And again, the units on that will be miles per hour. And I will let's let R be the speed of the river current. And that will also be in miles per hour. Now, a couple other key word here is we see that we have an upstream, and then in the return to the dock, that will be downstream. Right? So when we're returning, that will be downstream. So one thing that we need to know here that maybe you haven't seen before is that if it is upstream, the boat is working against the current. Whereas downstream, the boat is working with the current. We also know that distance is rate times time. So let's see if we can write a couple of equations using these ideas, using our variables and the information provided. So let's see what we have. The Mississippi boat sailed 120 miles upstream for 12 hours. So let's write an equation for upstream. Distance is rate times time. All right, well, the distance upstream is 120 miles. And that's a rate times a time. Well, let's hold off on the rate for just a moment. Let's put some parentheses here. But the time upstream was 12 hours. And upstream is working against the current. So the boat's speed and the river's speed are working against each other. And so what happens is we have to subtract the rates. And so the upstream rate is B minus R. Now for downstream, on the way back, it's the same distance, 120 miles. It's a different time though. Now the time is 10 hours to return to the dock. But now I'm working, the boat and the stream and the current are working together, B plus R. So here's two equations that we can use to solve this system. Solve this problem. We have 120 is equal to B minus R times 12, and 120 is equal to B plus R times 10. Now we could apply the distributive properties on the right-hand sides of these equations and go from there. But what I would do is at this point, I would take this first equation and I would divide both sides by 12. And similarly for the second equation, I would divide both sides by 10. And this yields then two equations, and I'll switch the sides. If I divide both sides of the equation of that first equation by 12, I would have B minus R is equal to 10. And taking the second equation and dividing by 10, I would have B plus R is equal to 12. And now we have a simple, I would use an elimination here. So now, notice I have a negative r and a positive r. Now I'm going to add together. All right, add the equations using elimination. And what that would give me then is 2b is 22, and dividing by 2, b is 11. And now if b is 11, now we can use a substitution. And so then let's use the second equation. b plus r is 12. So 11 plus r is 12. And subtracting 11, r must equal 1. So our conclusion. The speed of the boat in still water is 11 miles per hour. The river current is 1 mile per hour.